Good evening, students. I welcome you for another important class, and this is going to be a revision class on work and energy, and we are going to solve a lot of questions on work and energy. Students, what we told you in work and energy, student, we told you what is work. Work is said to be done when you apply a force and there is a displacement in the direction of the force. So we defined the formula of the work, students. Work was force into displacement, and there is an angle involved in that, which is a cos theta, students. Then we have defined there are the energies which we are using, students. Kinetic energy and potential energy are the two mechanical forms of energy. The total energy, mechanical energy, was defined by as in the physics as sum of the two kinetic and potential energies. Then we told you there are different forms of the energies. You have seen chemical energies, then nuclear energies. We have told you thermal energy. So many types of energies. We told you light energy. Law of conservation of energy says that the total energy is conserved, but one form of energy can be converted into another form of energy. That is very important, students. The life is there because of the conversion of one form of energy into another form of energy. If such a conversion is not possible, then there will be no life, let me tell you. Whether you are breathing and then that inside your body, you know what is happening, metabolism reactions are taking place, chemical energy is being converted into the thermal or heat form of energy, calories which you are getting, photosynthesis of plants by the sun energy. So, students, the transformation of energy is an essential component for the very existence of life. And then we told you the rate of doing work. This was important. Why? Because two machines could do the same work in different periods of time. Two persons could do the same work in different periods of time. Therefore, we define rate of doing work, student, as power. Power is rate of doing work divided by time. And students, we told you some of the important things, that the commercial unit of electricity which you are using, and we also told you the power rating of different appliances. What is the meaning of all these, students? Here on the board there is a picture of rate of doing work, power. So when we talk of power, students, what we are mean by power? We said power is rate of doing work, student, rate of doing work. What it means? Power is nothing but work done divided by time. And you know work is what is work? Force into the displacement, or for potential gravitational potential energy, work is m into g into h, students. And when we said what are the units are important for every lecture, student, for every class, units are important. What are the units of work, students? What are the SI units of work? Can you tell me what are the SI units of work, students? What is the SI unit of work? Joule. And what are the SI unit of energy? Energy and work are having very close relationship. They also Joule, students. And what will be the units of power then? We talked of power, joule per second, joule per second, which is what we call as watts. So would we define, student, what is the meaning of 1 watt, student? 1 watt means 1 joule per second. When 1 joule of work is done in 1 second, that is equal to 1 watt. Since 1 watt may be less, therefore we have used kilowatts also. Kilowatt, students. What is a kilowatt? 10 power 3 watts, student. So 1 kilowatt is nothing but 1000 watts. Therefore, students, which will be 1000 watt will mean 1000 joules per second. So that is 1 kilowatt, students. Therefore, we have told you that different machines are designed to do different types of work on the objects. So there should be, there is a power rating, there is a power rating. What is the meaning of power rating, students? In other words, I have given another formula for power also. Power is work by time, work is force into displacement by time, power is also force into velocity. This is an important point when we write power as work by time, students. We are saying work is nothing but force into displacement divided by the time. So we can also, displacement by time is, what is displacement by time, student? Force into displacement by time. What is displacement by time, students? That is velocity. So we can write power is equal to force into the velocity. So V is our velocity. This is important, that the machine which is a powerful will be both having big force. F should be, F should be big, and V should be big. That means it should be, what we say, powerful machine means, powerful machine means what, student? It should be strong. So force applied is strong, as well as the velocity is fast. It is moving fast, student. Its velocity is high. So strong and fast. This is important because the power can be expressed in terms of force into velocity. So this is how the interconversion of unit is important for solving many numericals, which we are going to do today, students. Further, students, when I say there is a power rating, if you have a bulb, light bulb, students, it is written 60 watt. That means it will consume, student, 60 joules of electrical energy in 1 second. So in 1 second, 60 watt means what? Power is 60 watt. Power is 60 watt means, student, 60 joule per second. So that means the electrical energy it will consume is 60 joules per second. And that is the energy which gets converted into work, student, or that is the energy which is getting converted into light energy or heat energy. So when light bulb is lighting, there is a light energy, but not all the electrical energy will get converted into light energy. There will be some heat energy also which will be dissipated along with that. So total energy conserved means the total energy, whatever electrical energy is, that equal amount of work will be done, students. So the power means it will consume 60 joules per second. As you will see, then steam, electric iron steam, how much it is consuming? 2400 watts is quite a large amount. So it will use 2400 joules in 1 second of your electricity. Refrigerator is 200 watts, means it will consume 200 joules per second. And hand dryer is consuming 1800, you can say, joules in 1 second, students. So if we say there is a power rating, that means we can express them in kilowatts if the value is large instead of watt, student. Because if I say kilowatt, that is equal to 1000 watt, student. Therefore we use kilowatt also. So at your home, student, you are using electricity, and you are getting monthly electrical bill also. Therefore, a commercial unit of electricity has been defined. Commercial unit of electricity. What is the commercial unit of electricity, students? So commercial unit of electricity is commercial unit of electricity, students, that is given in kilowatt per hour, kilowatt hour. So the question, important question is, what is kilowatt hour in joules, students? Important question. What is kilowatt hour in joules, student? You have 1 minute to answer the question. Okay, you can try it. What is kilowatt hour in joules? Important. Kilowatt hour is a commercial unit of electricity because electricity is consumed at homes. So they call kilowatt hour as a one unit. 1 kilowatt hour is 1 unit of the electricity. The cost of the electricity is calculated on the basis of the units consumed. If you consume whatever units you consume in 30 days, how many kilowatt hours you are consuming in 30 days, students? That is what we mean by kilowatt hour. So 1 kilowatt hour will be what, student? How will we calculate this? I am saying 1 kilowatt. How much is coming? 1,000 watts. And okay, 1 hour is how much, students? 60 into 60 seconds. 60 into 60 seconds. So how much will be that? Because this is 1000 watt into 1 hour, that will be 1000. This is the joules per second. Watt is joule per second, and 60 into 60 seconds. So what we are getting, 36 into 10 3 power 5 joules, or 3.6 into 10 power 6 joule. That is the correct answer which was given by Vidhi. So 1 kilowatt hour is equal to how many joules, student? Important question for the paper. So this is our 1 unit of energy here. 1 unit of energy is equal to 1 kilowatt hour, student. This is what you are using at homes. The meter reading, this is a kilowatt hour meter reading which is given by the meter which is there at your home, student, by the electricity department. Kilowatt hour. Therefore, student, electrical energy used during a month is expressed in terms of the units. So 1 unit means 1 kilowatt hour. 1 unit means 1 kilowatt hour. Therefore, you can see, student, that energy is required to do any work. And when work is done on a body, what happens? That gets stored in the form of the energy. You lift a object to a height, what happens? That from the ground you are raising something to a height, supposing 2 meters, then there is a gravitational potential energy which is stored in that. And as it falls freely, student, what happens? The total energy is always same, student, conserved, but one form of energy gets converted into another form. The sum of the kinetic and potential energy will be same. So that is what the law of conservation said. You are using different appliances, you are using different types of things at your home, students. And when you are using a battery, when you are using cells in the torch, you say that there is a chemical energy which is stored, and that chemical reaction take place and they produce electrical energy. So there is a conversion of chemical energy into electrical energy. Similarly, you are burning petrol in the cars, then that gets converted into mechanical energy which runs your car, students. Therefore, you see that energy, work are the two things which are very closely related with each other, so much so that they are the same units. And you have seen that in physics, when we talk of work, displacement should be there, but the direction of displacement is also important, students, because the formula for the work was, what was the formula for the work, student? Work was f into s cos theta. You define, if this is the displacement, this is a force, then there is an angle. And you have seen that if the force is acting at 90 degree Force is acting at 90-degree students angle to the displacement. Displacement is in this direction. Force is at right angles to this. Then what will happen? Then cos 90 is zero. There will be no work done. Work will become zero. So you are carrying a bag on your head. Then but for that bag, which you are carrying, you are exhausted because it is a weight of the bag m into g is on your head, student. The force is acting vertically downward. Force is acting vertically downward, uh, but you are moving. Then the net work done for the move on the bag is zero. On the bag is zero because the force is at right angles to the direction of your movement, student. So students, you can see we have given you that potential energy can be positive, negative or zero. Work can be zero, work can be positive or negative, depends on the direction of the displacement and the force which is acting on it. Let us see some of the questions, students, which are asked on this chapter. Now, we also define a horsepower. You very important because student, you have seen that earlier the man used horses to do his work. Horse used to pull a cart. Horse like a engine. Horse was considered as an engine for the man for doing the work he wanted to do. And when the steam engine was invented, James Watt used this idea of the horsepower, that 1 horsepower is actually equal to 746 watts. This conversion is important for many numericals because question will be asked on that. The amount of work a horse can do in 1 second, 1 horsepower. So 1 horsepower, students, this defined by James Watt. The amount of work, one mechanical horsepower lifts 550 pounds or 250 kg by 1 foot in 1 second. Okay? That is the amount of work done by a horse in 1 second. So this was defined as a horsepower, student, and it is related with the watts, as you can see. 1 horsepower is equal to 1 horsepower is equal to 746 watts. 746 watts. Then how will we saying that horsepower is equal to W by 746? Some of the conversion units are important, students. We should be horsepower can be used, student, if required in certain papers. They may give you the conversion of the watts into the horsepower. Here, what we are saying, the question on the screen for us to do the calculations. What is the question? Two girls, each of weight 400 Newton. Two girls, each of weight 400 Newton, climb up a rope through a height of 8 meter. We name one of the girls A and the other B. Girl A takes 20 seconds while B takes 50 seconds to accomplish the task. What is the power expended by each girl? Student, you have 1 minute to answer the question. You have two girls. Weight, climb up a rope through a height of 8 meter, student. Consider it is a rope. ठीक है? Two girls each of weight 400 Newton. Weight is given, weight is equal to M into G is 400 Newtons for both the girls. Height is how much, student? 8 meter. 8 meter. And you have girl A, while how much takes girl, what is the power, student? Work done by time. Work here is your force. Force here is your weight. This is our force into displacement 8 meter and time, which is, so for this girl, what is the force, student? 400 newtons. Height is 8 meters. And how much time it takes? 20 seconds. 20 seconds. And what about the girl B? What will the power, what will be the rate of doing work by that? Also 400 newtons. Height is same, but 50 seconds. So what is the 20 to 20? So this is 160 joule per second watts. And how much is that? 50, 80, how much is that? 8, 64. So the, which is able to do more, which has more power, girl A or B, students? So the girl A has more power. You can see one power expended by girl A 160 watt, power of girl A, and power of girl B is 64 watts. So we can see that such calculations can be given in the paper to do the question, students, that how much the height was 8 meter and the value weight is same, so no problem. M into G is given to us, so question becomes easy. Next question, students. A boy of mass 50 kg runs up a staircase of 45 steps in 9 seconds. In 9 seconds. So what if the height of each step is 15? Find the power. Take G equal to 10 meter per second. So what is the power, student? W by T. W is what here? Work is force into the displacement divided by the time in seconds. So what is the force? 50 kg into how much? G value is given 10 meter per second square. So that is our 500 newtons is the force, student. Now the height of the staircase, which will be the displacement, how much height will be there? 45 steps. If height of each is 15, 45 steps are there, student, into 15 centimeter he is climbing, but you, these are the centimeters, you will need in meter, student, so you will divide by 100 to make it meters. How much is the value coming, student? This is around 675 by 100, 6.75 meters. So what will be then the power? Find the power, then what is the power, students? 500 newtons is the force. Displacement is 6.75 meter. And how much time he takes? 9 seconds, students. So what will be the answer? What will be the answer for these students? Multiply by this and this seconds. So Newton meter per second, Newton meter per second, Newton meter per second is nothing but your joule per second, joule per second, which is nothing but watt. So how many watts it is coming? 375 will be the answer if you will make the calculation, students. So we can calculate the power by this method. Can we proceed further, students? You are finished with this? Then I will proceed further. Next question on the screen. Electric bulb of 60 watt is used for 6 hours a day. Calculate the units of energy consumed in 1 day. In 1 day by the bulb, student. By the bulb. What is the power of the bulb, student? 60 watt. And then what is the commercial unit? Calculate the units. Units means what, student? We have to calculate the kilowatt hour, which has consumed in 1 day. In 1 day, how many kilowatt hour is? He uses 6 hours per day. In 1 day, students, how much hours he uses? 6 hours. So first you calculate the kilowatts, student. 60 by 1000 kilowatt, and how many hours you are using then? Kilowatt hours is 60 by 1000 for 1 day, student. How many? 6 hours. 6 hours. So this is our kilowatt hours. How much is that? 360 by 1000, student. So how many kilowatt hours that come? Kilowatt hour, how much? 0.36 kilowatt hours. This is the units which is consumed in 1 day. And 1 kilowatt hour means 1 unit. 1 kilowatt hour is 1 unit of your electricity which you are consuming. So 0.36 units consumed in 1 day. Calculate the units of in 1 day by the bulb. So this is an electric bulb, students. When we try to solve numericals or questions, students, even before formula, if we make a picture or visualize the question in our mind and form a picture of that, then it becomes easy to solve the question. Then whatever basic concept is there, we can use it. Before that, we have to make it visualize the question very clearly before you answer it, because then it is easy for us to answer the question. Very important to understand the question before you answer the question. That's what we are saying. Understanding is required. Calculate the power of electric motor that can lift 800 kg of water to store in a tank at a height of. So what you are saying, that there is a tank, student, water tank. This is my water tank in which we are storing water. There is a pipe, student. How much height? There is a motor. Here is my motor, students. Electric motor which will throw the water. The water is going up from this motor to a height of 1500 centimeters is the height. H. And how much water? Lifting 800 kg. Mass of the water is 800 kg, students. Height is 1500 centimeters, which will mean 1500 by 100. 15 meter students, and the value of G is already given 10 meter per second inverse. So what is the force students? M into G. M is 800 kg. G is 10 meter per second inverse. That will be 800 into 10, 8,000 Newton, which is the force students. And then what is the power? W, rate of doing work. Force is 8,000 newtons into displacement is how much students? 15 meter divided by how much time in 20 seconds. That is our answer students. You can cancel 0 with 0. 2400. How much it becomes? 6,000 joule per second, which is 6,000 watts or 6 kilowatt. So students, like this we can calculate the power. Questions, numericals will be asked in your exams. We must practice as many numericals as possible. They are very important for the paper. So once you make a picture of what you are doing, then it becomes easy. How the water is going in the tank. Okay, students. Next question. You are finished with these questions, students? Then we will go to the next question. Calculate the electrical energy consumed in joules if toaster of 60 watt is used for 30 minutes. Student, you are using a toaster. ठीक है? Power of the toaster is how much? 60 watt, 60 joule per second. That is the power. And what is the formula power? Work. Power is work into displacement by time. How much that? Which is also the electrical energy. Electrical energy. So power is W by T, students, or here I can write, just make it more easy for you. Here, what is work is nothing but electrical energy. I am saying electrical energy, which is E. This is my electrical energy, students, by time. So electrical energy is how much, student? Then electrical energy will be equal to power into time. So you have 60 joule per second into time. 30 minutes means 30 into 60 seconds, 1800 seconds. So we can calculate the value in electrical energy in joules, students. How much is coming? 108 into 10 power 3 joules. So this is the electrical energy which will be consumed by the toaster in 30 minutes, students. Your toaster will consume 108, or I can write 1.08 into 10 power 5 joules of electrical energy in 30 minutes. If you are using the toaster for 30 minutes, the power is 60 watt, it will consume 1.08 10 power 5 joules of energy. ठीक है? Or you can say 108 kilojoules of energy. So questions, numericals are important in this chapter, which we should be able to do. An electric heater of 100 watt is used for 2 hours in a day. What is the cost of using it for a month of 28 days if one unit costs 3 rupees, students? Now here is the electric bill which will be coming. So question has been put on that. Electric heater of 100 watt, 1000 watt, power 1000 watt. How much it is used, how many hours student it is used, how many hours it is saying 2 hours a day, and a day is how many, 28 days, a month has 28 days, so how many hours it is being used, 20 to 8 into 2, 56 hours you are using it. 56 hours means what? So first you find kilowatt, 1000 by 1000 is 1 kilowatt. Then you find kilowatt hour, 1 kilowatt into 56 hours, student. So 56 kilowatt hour is the consumption in 28 days. How much units you are using in 28 days, students? You are using 56 units, which is equal to 56 units, and the cost of 1 unit is 3 rupees. This is 3 rupees. So the what will be the cost? 56 into 3. So this is the cost in rupees, student. 168 rupees will be your cost of 28 days for using the electric heater, the which consumes 1000 joules of electrical energy in 1 second. You are using it for 28 days and you use it 2 hours a day. This is the way we make calculation, student, in terms of the electric bills or other type of bills at our homes. Any doubt, students? Is there any doubt to any student? Okay. Next question. You have 2 minutes to answer this question, students. Calculate the electricity bill amount for a month of 30 days if the following devices are used specified. You have to calculate your electricity bill for 30 days. For 30 days. You have to calculate the electricity bill for 30 days. What appliances you are using? You are using 2 bulbs. 2 bulbs are 40 watts. 2 bulbs of 40 watt means 2 into 40, 80 watts. 80 watts, that means 80 by 1000 kilowatt, student. 6 hours you are using into 6 hours. How much it comes? What? 80.480 kilowatt hour. So this is the units. Which units? How many unit? 0.480 kilowatt means 0.480 units, students. consumed by two bulbs. And what is the next one? Two tube lights, of 50 watt. 50 watt means 2 into 50 watts, 100 by 1000, that is zero point 0.1 kilowatt. 8 hours you are using, 8 hours. So calculate for a month of 30 days, 30 days. If following devices are used as specified, two bulbs for 6 hours, two bulbs you are using for 6 hours, two tube light you are using for 8 hours, students. How much is that? 8 hours. So how much it becomes? Zero point 0.8 units. 0 point 0.8 units. Then, which is the third one? You are using a TV. How much is that? 120 watts. 120 divided by 1000 watts. ठीक है? For 6 hours. So how much you get? 7.720 kilowatt hour will mean 0.720 units. So what is the per day the units which you are using? How much? Add all this. 0.480 plus 0.8 plus 0.720 units. Per day, our consumption is this one. So how much it is coming? 2 units. Total 2 units per day. And you are using for 1 month. 1 month has got 30 days, students. 30 into 2 means 60 units. And 1 unit is costing how much? 2.50 per unit. The cost 6. The cost is then, students, 60 units into 2.50 rupees. So how much is the value? 0, 0, 0, 0, 150 rupees. So 150 rupees is the expenditure, student, for the consumption of this, which we have told you, for the month. Any doubt, students? Any doubt? How do we calculate the units consumed, electricity bills in this chapter? What we are doing, the power, rate of doing work. Any doubt? Okay, very good. You have noted down everything, students. You have noted down everything. Very good, students. Numericals are important because such questions will be asked to us in the paper. We have to be sure, student. So here is another form of question. He says now, what is the unit of energy, students? What is the unit of energy? We already answered that question, Joule. The total energy when a body falls freely towards earth remain constant. Is it true or false? Is it true or false, student? What is your answer, students? Total energy remains same when body falls freely. Is it changing or total energy will remain same?
Sir, it will remain same.
Yes, correct answer. The total energy will always remain constant. The total energy and body remains constant. Law of conservation of energy. It is true. Law of conservation of energy. Yes, that is the correct answer. Next, what do you mean by kinetic energy of the body, students? What do you mean by kinetic energy of the body?
Sir, the energy possessed by a body because of its motion is called as kinetic energy.
Correct answer. Motion. The formula is also known to you. What is the formula of kinetic energy, students? Half mv square. If mass of a body is doubled and velocity is made half, the kinetic energy will become. What will happen to the kinetic energy? Half. If mass of the body is doubled and velocity is made half,
So the kinetic energy will also become half.
half. So this will become half. ठीक है? 1 by 2 of kinetic energy. Okay, correct answer. Potential energy is a vector quantity. True or false, student?
False, sir.
Yes, that is a correct answer. Potential energy is not a vector quantity. It has no direction. It is only because of the position of the body. So, when the force acts at right angle to the direction of motion, what is the work done by the force, student? Again and again, we are asking this question to you.
So the force is zero when the force acts right angle to the direction of the motion.
Work is zero. This is 90-degree force, and this is the direction of the motion. So, F into displacement into cos theta. Cos 90 degree is, students, cos is, let me make things clear to you. So the work is equal to F into S into cos 90 degree. Cos 90 degree is, 0. So W will be 0. Work done will be 0. What is power? You already have been
Sir,
told.
it is defined as the rate of doing work by the
Yes.
body.
Okay. Power is rate of doing work, students, which is W by T, and the unit joule per second is watts. What is law of conservation of energy? Important question, students. Before you already answered the question. What is law of conservation of energy, students?
So the law, this law, and in this law, energy can only be converted from one form to another. It can neither be created nor be destroyed.
And total energy remains constant. Okay, that is the correct answer. Thank you very much for answering all the questions. And this ends up our revision as well as some numericals on the topic of work and energy. Next time we will have a quiz context, student. We will meet you in the next class for a quiz competition. Thank you very much. And then I will see you in the next class. Okay. Bye bye, students. Thank you for interacting and
Thank
answering
you, sir.
questions intelligently. Bye bye.